So here we have exponential decay. In the previous lesson, you had growth, which was 1 plus your rate as a decimal. With exponential decay, you're going to do 1 minus your rate as a decimal. So let's fill in. This sheet is found on your haiku page, or pause the video and zoom in, however you're most comfortable. So with exponential decay, we're still dealing with f of x equals a, our original amount, but with decay, we're going to do 1 minus our rate as a decimal. So a is still the initial amount. That's what we start with. R is going to be our rate of decay instead of our rate of growth, like we did on the previous problems. And then t, of course, is our time. So let's look at problem number 7 and see how we can set this one up and how it's going to differ from the one we did before. So the population of a town is decreasing. That right there, decreasing, losing value, tells me I'm dealing with exponential decay. So it's decreasing at a rate of 1% per year. In 2000, there were 1,300 people. Use an exponential function to find the population in 2008. So let's go ahead and fill in our A, our R, and our T, and then we'll plug it into the formula and see what we're going to have. So A is going to be our initial amount. It tells us that there were 1,300 people in 2000. That's where we're starting this function in the year 2000. So 1,300 people is going to be our initial amount. And again, people. Now, R is going to be our interest rate. We're dealing with 1%. Change 1% into a decimal by moving it 2 places to the left, and that's going to give you 0.01. And then our time. Well, they just didn't give us a flat out time, did they, like the other problems we were talking about. So look and see what you're told. In 2000, there were 1,300 people. We want to know how many people did the town have in the year 2008. So you've got to calculate how many years there are from 2000 to 2008. That's easy enough, isn't it? So we're going to have 8 years. Let's plug into our formula. Again, I'm going to change f of x into y just to save a little space, because we know f of x is function notation that takes the place of y. Interchangeable values here. So A is my initial amount at 1,300 people, and then we have 1 minus our rate. Make sure when you're doing decay, you do 1 minus your rate, because B has got to be in between 0 and 1 when you're talking about decay. So 1 minus your rate as a decimal, and then we'll raise it up to our years, which is 8 years. And notice we're talking about 1% per year, and we have a time of 8 years. Both of them match in years, so we're in great shape. So let's do 1,300 times 1 minus 0.01 to the 8th power. So 1,300 times 1 minus 0.01. Let me clear that. Something didn't click there. 1 minus 0.01. And we're going to raise that up to the 8th power. Okay? Your calculator can handle it. You don't have to simplify what's in the middle unless you want to. And then when I click on this, this is my answer. Okay? And again, we're talking about people. So with people, even though this would round up, let's leave it at 1,199. Okay, so let's go back to our problem here, and we'll have 1,199 people, okay? And so that will be the town population after 8 years. So notice that the population started with 1,300 people, and then after 8 years of declining population, we ended up with 1,199 people. So we did decline in value. Let's look at number 8. The value of a car is $18,000. Shouldn't that be our initial amount? And then it tells us it is depreciating. Depreciation means it is losing value. When you buy a car, it starts losing value from that point. So that's what depreciation or depreciating means. It is losing value. So that's why this is in the exponential decay portion of our lesson. And it's depreciating at 12% per year. We want to know how much our car is going to be worth after 10 years. So, A, our initial amount is going to be the $18,000. Our rate, which is going to be 12%, let's change that into a decimal by moving it 2 places to the left. And we'll get 12/100ths. And our time, notice that we're 12% per year, and our time is in 10 years. So since they're both in terms of years, we're in good shape. So 10 years. All right, so let's plug this in. We've got Y is equal to our money, $18,000, our initial amount. But because this is decay, make sure you do 1 minus your rate as a decimal. So my rate as a decimal is 0.12 or 12/100ths. Now my time is going to be my exponent of 10 years. So 18,000 times 1 minus 12/100ths raised to the 10th power. So 18,000, 1 8 and 3 zeros. Okay, then we'll have 1 minus, because we're talking about decay, 12/100ths. And then we're going to raise it up to the 10th power because we're looking for the value after 10 years. So plug that in. Now this is money. We're talking about money. It's okay to round money. So let's go out to 2 decimal places and you'll see that this 7 will round the 1 up to a 2. So $5,013.02. Okay, so our car started off at $18,000. After 10 years, it's now worth $5,013.02. Number 9, a farmer buys a tractor for $50,000. If the tractor depreciates, again that means to lose value, at 10% per year, write an exponential function to find the value of the tractor in 7 years. Now is a good time to pause the video and work this problem out for yourself and then see if you get it right. So pause the video, work it out, and then I'll work it out. All right, let's see how you did. A is our initial amount. This is how much the tractor was worth when we bought it, $50,000. R is our rate, which is going to be 10%. Let's change that into its decimal equivalent. Move your decimal 2 places to the left, and you get 10/100ths, which is 1/10. Okay, I just dropped the 0 at the end. And then our time, notice our percentage is 10% per year, and our time here is 7 years. So we're in good shape with those 2 matching. Let's plug in. Y equals our initial amount of our tractor, that's $50,000. And then 1 minus our rate, which is going to be 1/10, raised to our time, which is 7 years. 50,000 times 1 minus 1/10 raised to the 7th power. In your calculator, you will have $50,000, and then 1 minus my 1/10, because this is decay, it has to be minus. And raise it up, forgot what year that was, 7 years. So raise it up to the 7th year. Okay, plug it in. Now we're talking about money again, so rounding is good. So $23,914.85. What was that? 85 cents. Okay, and so our tractor went from $50,000 to $23,914.85 in value. So the value decreased because it was depreciating or losing value, okay? So what you need to do tonight as your assignment, I've already given you the first three, or the first three growth problems. You need to do 4, 5, and 6 on the growth page. Now, I just did 7, 8, and 9 on the decay. You need to do 10, 11, and 12. After you finish, take a picture and email it or send it to me through Remind, either one, and I will look over those and see how you did. We're also going to do more growth and decay tomorrow. Wednesday, we're going to do compound interest, and then we'll practice up and quiz on Friday. If you have any questions, be sure to send me a message and I'll be glad to help. Y'all have a great day.